Hello, everyone, and welcome to Powering Experiences, brought to you by Samsung Semiconductor Inc., a show where we sit down with leaders in the field of semiconductor memory, storage, processors, sensors, and everything in between to take a closer look at the intersection of advanced technology and everyday life. I'm your host, Nick Stoll, and we're here today with Tien Shiah, our Senior Manager of Memory Marketing. Tien has worked in product marketing and as a product manager, and he's joining me to talk about AI and its upcoming applications in gaming. Hi, Tien. Welcome. For our listeners, if you could, tell us a bit about yourself and your role at Samsung.
Sure, I'm happy to be here. So I've been at Samsung for about 7 years now. I started off in product marketing for the storage area. And then in the last 4 years, I've been in high-speed DRAM product marketing. So this type of memory is typically used in applications that require very high performance. So things like AI and computer graphics are certainly a couple of those areas.
Yeah, and so it kind of sounds like just the nature of your job already puts you at that intersection of AI and gaming. And so, from a very high level, can you share some insights into how artificial intelligence is going to significantly impact the gaming landscape?
Sure. So if we think of AI, I mean, AI is all around us today. Basically, bottom line in terms of what AI does for us is improve the user experience, right? So whether it be things like autonomous driving that people are talking about, improving the shopper experience to, affecting how games are played and displayed. So one of the areas that it certainly impacts gaming is in terms of visuals, right? Improving visuals in gaming.
Yeah, and to kind of drill down on those visuals you're talking about, I think we've used the term in some of our social media posts and things we put out there, upscaling. And what is that upscaling? How does it benefit the players, and like what does it mean to them?
Sure. Upscaling is basically a way of improving the graphic fidelity, right, of or the resolution and the frame rate, right, of the game to the user. So there are many ways to do upscaling. One of the ways in which AI is improving the graphic fidelity is in technologies such as DLSS. So that's technology that's developed by one of our customers, NVIDIA. It stands for Deep Learning Supersampling. It's an example of, like I said, using AI to get better frame rates, where basically, deep learning is used to essentially upscale lower resolution images to high resolution with less computation. So without using this technology, you would have had to have much higher processor and memory speeds than you would need to, because they do this by using essentially a neural network that's trained in the data center to map ideal images to their lower resolution counterparts. And they do this correlation. And once this network is quote unquote trained, in AI we talk about training. Once this is trained, the data is basically packaged and sent to the user in the form of a game driver. So if gamers are probably familiar with drivers that that they need to update on occasion. So these are basically improvements that the developer makes as time goes on, and then they update the driver, and the user uses the latest driver that has these trained networks contained with it to improve their gameplay.
Yeah, and as someone listening, they might think the AI is helping, see better images with less processing power, but they also might think they know AI takes a good amount of computing power. So how does it end up benefiting the computer and that processor for the gaming? And what's that trade-off between memory and processing, and how does AI actually bridge that gap?
Yeah, like I mentioned, the as it applies to DLSS, it's trained actually on much powerful computers in a data center. Like these are big servers, right? That actually crunch does the training on the neural network, which is, a lot of these neural networks are billions of nodes, right? So it's not something that you can do on a home PC.
Mhm.
So it's done in a big data center. But once the result is completed, the result of that is packaged in the form of a driver that's sent to the end user, so they can use their standard PC to take advantage of something that was essentially computed and completed in on much larger, more powerful computers.
Yeah, excellent. And I mean, we both know that, AI is just not helping, images look better. It does way more than that.
Mhm.
Another one of the things you've kind of worked with and spoke about before is natural language processing. So, how does that natural language processing, help gamers, and how does it improve their experience?
Sure. So if you think of player interactions, right, with basically computer characters, the non-playable characters or NPCs, right? A lot of these are scripted dialogue today. So you kind of know after playing the game maybe through a couple of times how the NPCs would react, right, and speak back. So it's very limited. Um,
Yeah.
Using natural language, uh, basically generation, which is something that we can do today with AI, with the large networks that we're talking about, it makes the interaction much more lifelike and realistic, right? But this obviously takes a lot of compute power. So if so we're not showing anything visually today, this is
Hmm.
since this is a podcast, but just verbally I'll kind of go over the size of these neural networks that are required. So if we talk about maybe 6 years ago, a state of the art neural network for computer vision that was developed by Microsoft, called ResNet, for those people familiar with neural nets. It had 26 million parameters for training. Compare that to language generation, it's 175 billion parameters. So we're talking basically, orders of magnitude larger, right, in terms of processing power that's
Yeah.
required. And this is over the span of just last 6 years, right? This is why basically a lot of companies need very, very high speed memory, because a lot of people, when they think about a compute problems, they just think about throwing more compute power, right, to solve the problem. But a system, you have to know where the bottleneck is. And a lot of times, the bottleneck isn't the processor speed. The bottleneck could be the memory that's in the system. So you got to balance that out. And what we're finding, and what a lot of our customers are finding, is that memory is really the bottleneck in the system, not necessarily the processor. So that's where Samsung memory, this Samsung high speed memory, comes into play.
So, what kind of Samsung memory is being used by our customers who do this kind of high performance computing?
Well, high bandwidth memory, which is HBM, which is one of the memory products that Samsung provides, is being used already in a lot of these training applications. So our top customers, and a lot of startups right now who are designing ASICs for AI applications recognize that HBM memory is kind of the memory of choice for AI, because they need the speed. No other form of DRAM matches the speed of HBM. So it's become that memory of choice when people need to run their AI applications.
All these games nowadays have these in-game purchases.
Mhm.
You got things to buy, whether it's a new skin or a wrap or bells and whistles, or even some content and stuff. So how does AI end up in that space, and how can it affect in-game purchases, and how can that actually help the gamer rather than kind of target them?
Yeah, so what you're speaking to is kind of a form of data mining, right? So certainly another area where AI helps the game developer tremendously from a revenue standpoint, right? So We all kind of understand how Amazon, looks at consumer behavior and provides the best recommendations to improve your shopping experience, right? That's a form of data mining. And that's done by observing user behavior while they're on their site. So games do something similar as well. While the user is playing, basically the game can observe the user's behavior and tendencies and see what the user likes to do. Um, and from this learning of behavior, recommend popular items for the gamer to purchase, right? So whether it be to improve a certain skill or to add certain skins based on the type of characters that they like, all these in-game purchases help fund the development of additional games, right? Because many popular games today are free to play, right? So you kind of wonder, well, if you don't need to buy the game, they're free to play. Well, how does the developer make any money out of this? So they analyze how people use the game, and then they have in-game purchases to do that.
And if I could summarize kind of what we've talked about, in the very near future, it sounds like gamers at all levels will start to see AI and how it can influence their predictability, the intelligence and adaptability of a lot of their favorite games. And is there anything else on top of that you think our listeners should know about this upcoming frontier in gaming?
Yeah, so we talked a little bit about this maybe earlier in terms of how NPCs or non-player characters traditionally, their behavior is more predictable over time, not only in the way they interact, but in the way they might be fighting in a game if you're playing like a first-person shooter.
Mm-hmm.
That's because they use decision tree techniques, right? So it's built-in algorithm. So once you play the game long enough, the players know how to defeat it. This is something players call, artificial stupidity, right? Because you can kind of predict how the algorithm is going to react. So using AI, you can have adaptive, intelligent behaviors to bring about more human-like gameplay, right? But of course, you don't want the AI to be super smart that nobody can beat it, right? You want it to get
Exactly.
to kind of a level where it's kind of like another good human player, right? And if you think about AI when it's used for this purpose in games, it started with strategy games, right? Like chess, right? That's traditional one. And Go. Go was considered a very difficult game to use AI, but now the best chess and Go AI beat the very best human players in the world, right? So basically, humans can't beat these AI machines you know if you tap it to its full potential. So I think what's important is to make the AI smart enough to make it challenging, but not impossible to beat.
Yeah, I know I myself could definitely use a little bit more of that artificial stupidity while I'm playing. Um, well, Tien, thank you for joining us today. You've been fantastic, and we're really glad you came on. You've been listening to Powering Experiences, brought to you by Samsung Semiconductor Inc. The show's executive producer has been Melanie Nelson. Producers include Lisa Warren Plungy and Danny Pugh, with creative direction from Andrea Karim. Until next time, I'm your host, Nick Stoll. I hope you learned something today.